Hey, there's a quick crash course on everything we weren't able to cover as far as the homework goes. This is the block and the bullet problem. Case 1 is when the block is in a vise. Case 2 is when it's on horizontal friction on the surface. So case 1, we got this equation, no problem. All I did different is I said F is in terms of V. This mass and this distance is known. Keep in mind that this distance and this distance are not the same. This is the known distance and this is the unknown that we're looking for. I just didn't want to give it a different subscript, but everything else is consistent. Just so you know, this is the mass of just the bullet, this is the mass of the two bullets and the block system. So then this must be the velocity of that system, and these velocities, since they're denoted the same, they are actually the same. And we got that too. We got the second equation as well. But anyways, I call this equation 1. It's in terms of F and V, neither of which we know. Equation 2, which I didn't do with a conservation of momentum first. Just remember, do how I say to do it, not how I actually did it. I always have this first before you do conservation of momentum. But anyways, it simplifies into this, and we don't know V final and we don't know V. So I solve for V final in terms of V, and these masses are known, and I just call that equation 2. Equation 3, what's important to keep in mind, this is what was giving you trouble. So what's important to keep in mind is not all of the energy from the bullet gets lost on the block. Some of it gets transferred into keeping the block moving afterwards, and that's why our distances are going to be different. And it makes sense that this distance would be less, just because intuitively it seems like if the block keeps moving afterwards, that the distance the bullet penetrates should be less. And we find out that's what happens, and I call this equation 3. So we plug in 1 and 2 into 3, and so for force I plug that in here, and for V final I plug in that over here, and we see if we squared this V final, we get a V squared here, and we have a V squared here, and we have a V squared here. So all those V squareds, they cancel. Everything else is a known other than the D, which we're looking for, and we get 7.94 centimeters. And that's it. It's a good amount of algebra. You can either solve for it in terms of variables, which I like, or just plug in the numbers in if you need to. As long as you get the question right now, that's the most important thing.